Welcome to our series on math properties. In this tutorial, we'll be going over three properties of addition and multiplication. We'll discuss the commutative properties of addition and multiplication, the associative properties of addition and multiplication, and finally, the identity properties of addition and multiplication. So let's take a look at the commutative properties of addition and multiplication. So what does that mean? Commutative. What it means is that when you're dealing with a problem that involves only addition or only multiplication, there are certain things that you can do. For example, 9 plus 3 is the same thing as 3 plus 9. It doesn't matter which position the number finds itself. In this particular example, 9 plus 3 would give us 12, and 3 plus 9 would also give us 12. So the answer is unchanged. Let's take a look at the next example. 6 plus 5 plus 7. That's the same thing as 6 plus 7 plus 5, in which I change the 5 and the 7 position. And that's the same as 7 plus 6 plus 5, in which I put the 7 in the first position. If you add all of these together, they're going to give you the exact same thing. So, in this first example, I have 6 plus 5, which gives me 11. 11 plus 7 would give me 18. In the second one, I have 6 plus 7, which gives me 13. And then when I add 5 to it, it also gives me 18. And then in the final example, 7 plus 6 gives me 13. And again, if I add 5 to 13, I get 18. So all of these, regardless of the position, would give me the same answer. Okay, now what happens if I'm dealing with variables? Again, as long as the operation is only addition, you can move the items around and it wouldn't matter. Let's use an example in which I say that x is equal to 1, y is equal to 2, and s is equal to 3. Okay, so let's see what happens. Here, that would mean 9 times 1 plus 4 times 2 plus 3 times 3. Here, 4 times 2 plus 9 times 1 plus 3 times 3. And finally, 3 times 3 plus 4 times 2 plus 9 times 1. And as you can see, if I go ahead and solve for this, 9 times 1 is going to give me 9, 4 times 2 is going to give me 8, and 3 times 3 is going to give me 9. Let's go ahead and do that for all of them. 9, 8, and 9. And when I go ahead and I add 9 plus 8, that'll give me 17. 17 plus 9 will give me 26. And in the second one, 9 plus 8 will give me 17. 17 plus 9, again, will give me 26. And finally, 9 plus 8, 17, plus 9, 26. So in every example, regardless of the position of the items, I get the same answer. That is what we call the commutative properties of addition. Now let's look at multiplication. In the first example, we have 9 times 3. And in the second part, we have 3 times 9. So if you know your timetables, you know that 9 times 3 will give me 27. But 3 times 9 also gives me 27. So I get the same exact answer. All right, let's look at the second one. 6 times 5 will give me 30 times 7. And 30 times 7 will give me 210. All right, let's see if I get the same answer if I move them around. 6 times 7 gives me 42, and 42 times 5 will give me 210. Okay, now if you don't believe me, do it on a separate piece of paper just to make sure that I'm doing it correctly. In the last example, I have 7 times 6. 7 times 6 gives me 42. And 42 times 5, again, gives me 210. Okay, now in the last one, I have variables. Okay, again, I will give these variables a value. So that way we can double check to make sure that the commutative property of multiplication actually works when we have variables. Again, I'll keep it simple. I'll make x equal to 1, y equal to 2, and s equal to 3. And since they're variables, they can have different values. So x could equal to 4, y could equal to 9, s could equal to 1/2. So variables are able to change. So in the first one I have 9 times 1 times 4 times 2 times 3 times 3. Okay, so let me go ahead and do the same thing with all of them. Change out the variable. 4 times 2 times 9 times 1 times 3 times 3. And finally, I have 3 times 3 multiplied by 4 times 2 multiplied by 9 times 1. Okay, so let me go ahead and do it at the bottom so that way we have more space. So 9 times 1 is 9. 4 times 2 is 8. And 3 times 3 is 9. Here we have 4 times 2 is 8. 9 times 1 is 9. Multiplied by 3 times 3 is also 9. And finally, we have 3 times 3, 9, times 8 times 9. And if I solve, 9 times 8 gives me 72. 72 times 9. Okay, I'll go ahead and do it on the side here because I can't do that in my head. 9 times 2 is 18. I carry the 1. 9 times 7 is 63 plus 1, 64. So my final answer will be 648. So let's see if I get the same thing. Here, 8 times 9 will give me 72. 72 times 9 will give me 648. And the final one, 9 times 8 is 72. And 72 times 9 will give me 648. Okay, now let's look at these numbers. What if I had 9 times 9 first? So let's say, for example, I had 9 times 9 times 8. Would I get the same answer? Well, let's check it out. 9 times 9 gives me 81. And 81 times 8, let's go ahead and do that on the side. 8 times 1 is 8. 8 times 8 is 64. Yeah, check it out. We would get exactly the same thing. 648.